today is welcome to today's live session. Today is going to be one of the first demo sessions that we are having, and the actual classes will start from the second week of June. So so let's start this session by introducing myself. So my name is Anjani, and I work as a software development engineer at Amazon. So I too was once a former student of Logic Mojo. I did my preparation and everything from Logic Mojo itself. So yeah, that's pretty much about me. So before starting this entire session, I would like to uh, point out a couple of things which would help you guys to decide like whether this course is right for you or not. So since today is a demo session, I will be solving a couple of easy to medium basically interview problems. So they won't be much harder because I know there are many people who have a lot of experience in this industry, and there will be some of the people who will be very new to the industry, or maybe like some of you guys would be college student as well. So just to keep a balance, today I will be picking up 4 problems. I'll let you know like which problems they are in a minute. But the point is that these problems don't require any prerequisite such as binary tree or linked list. So today we will be focusing more on these sort of problem. As we go deep into the course, we will be solving much more complex problems than these. And yeah, so that was one point that I wanted to talk about. Second point is there are a few prerequisites for this course. Like by prerequisites, I mean it's good to know, like it will help you to understand the concepts in a better way. So I would recommend that whichever data structure that are present in the syllabus, you should have a basic understanding of all of those data structures. So for example, if what do I mean by basic understanding? So for example, if I take a binary tree, for example, you should know at least these 3 things. Like what is binary tree, how to create a binary tree, how to insert a new element in a binary tree, and how to delete an element from a binary tree. And like if you are interested, you can also learn how to search in a binary tree. So these things are pretty simple. We will be going over them when we reach, when we start teaching binary tree. But if you, like know a little bit about it, it's good for you. Like it will help you to, grasp your subjects easily. So yeah, that's one more thing. These are the prerequisites. So for every data structure that you have, it's good to learn these. So there are plenty of internet resources out there which teach you these things. So just have a look at it. Another thing is for any of you having any course related doubts, you guys can reach out to the Logic Mojo team for that. So after this session, you can reach out to them and they can clear any doubts that you might have. And last thing is the language, like which language I will be teaching in. So whenever I'm starting a new problem, what I will do is I will be first explaining the logic by a visual representation. Like I will dot diagrams and explain it to you like this is happening this way. And once that part is done, I will write the code on this pad itself. So that will be the pseudo code. It will basically focus more on the logic rather than syntax. And after that, I will, show how the code looks like, and, the same thing in Java, Python, and C++. So these were a couple of things that I wanted to, mention before starting the course. So in today's session, we will be first starting with the big O notation. So I know most of you have the knowledge of big O, or like time complexity and space complexity, as we say. I just want to, go through it a little like quickly, so that, some because when we will be solving these problems, we will be discussing the time complexity and space complexity of these problems, and a little introduction of them would help. After that, I will be solving some interview questions, like questions which are, generally asked in the interviews. So I'll start with sorting an array of zeros, ones, and twos. So this question is pretty famous in interviews. So generally what happens in an interview is you are given two questions. So like this is a general case. Sometimes they can ask you a single question only. But what happens is when you are giving an interview for a big product based company or any like big tech company, what happens is generally some candidates feel a little nervous while going into the interview room. So what they do is they partition their entire technical interview of 1 hour into two parts. The first part is the easy questions, like easy or medium questions, which you can, which they expect candidates to solve within the first 15 minutes. And then the rest of the 45 minutes, they focus on a much more complex problem. So this question comes in the first category. Like this is not that hard to, code. So it will be like if someone knows the solution, they can solve it in like 15 minutes. And that gives them a, confidence boost and they get a little comfortable in the interview room. So this works as a starting point in an interview. So this is one of the famous questions, which is very frequently asked in interviews. Second problem that we will be discussing today is moving all zeros to the end. So this question is very similar to the above question. And many candidates, what they try to do is they try to use the same logic in this question as well. But generally what happens is like that's not a good idea to do. And I will be discussing why that's not a good idea. But yeah, this is also one of the questions that I will be taking up today. Then we will be going through finding the missing number. So this is a very basic program, like but there are multiple ways to solve it. Like what happens is in a problem, there are multiple ways you can solve a particular problem. So it's better to know, all the cases, how to, because in an interview, you shouldn't just directly jump to the most optimized solution. You should first start with the brute force and gradually increase your way to the most optimized solution. And last, this is a little complex problem, which is the jump game problem. This is very famous and it, yeah, sure. So, sorry. So as I was saying that for jump game problem, what happens is like this is actually a greedy algorithm based problem. And I know many people out there have trouble in understanding greedy technique and dynamic programming problems. So what I want to say here is it's very easy to get frightened by these topics, but that's why I'm picking this problem today, because it's not very hard when you look at it from a certain viewpoint, because there are pattern in all the programming problem that you solve these days. So once you know that pattern, it's very easy to solve them. So I'll be picking up this question as well. So yeah, with that, let's start today's session. So first is the big O notation or the complexity analysis. So first question which might come to your mind is why use big O? Like why use time complexity? So time complexity is used to determine how much efficient your code is. When you're writing a code, you should know how much pressure it can handle, how much user base it can handle. For example, a very simple example would be Hotstar's live streaming. So for example, like when they are streaming a live cricket game, they need to know how much user they can support at the same time. For example, in 2019 Cricket World Cup, in the semi-finals, India versus New Zealand, there were 2.5 million people. That's 25 crore people. So they need to know that, they can support that much user before live streaming, because if their service goes down at that moment of time, it's very bad publicity for them. So this is why analyzing your code is very important when you are working for a company, especially if the company is like dealing with is basically dealing with large scale systems. So yeah, so with that I would start with a very simple analogy, and I will try to map that analogy with the concept of time complexity. So let's say you are working in a company and you are situated in Delhi. Okay, so when you are situated in Delhi, you have a file, okay, and you need to send it to one of your colleague who is sitting in Bangalore. Okay, now the question is, how will you do that? So of all the options that are there, if I categorize them, they will mainly come under these two categories. One is the electronic transfer, which means either share it via mail or upload it in a cloud server and share it with them. and these sorts of techniques. Another way is physical transfer. Now, as soon as I say physical transfer, I mean that guy can you can get up from Delhi and go to Bangalore and personally deliver it to him on a hard disk or something of that sort. Now, this sounds funny right now because like this in these days, no one would like to go to Bangalore. Like no one does that, right? Because it may be it was a viable option during the 90s, but definitely not today because we have very fast internet and everything. But still, I haven't told you what the size of the file is, right? So if the size of the file is, let's say, 10 MB or 1 GB or 10 GB for that matter, that's not a very, big deal because it will hardly take 5 to 20 minutes depending on the size. And you can send it to him via any cloud desktop. That's fine. We can all do that. But what if I say the file that you want to send is of size 50 TB to 100 TB in size? Even with your fast internet speed, it might take you 2 to 3 days to just upload that on your cloud desktop. And then it will take another 2 to 3 days for that guy to download that. So that's a total of 6 days. Whereas a flight only costs like around 5 hours of your time to reach from Delhi to Bangalore. Like I'm just assuming a number. So for smaller files, that's a good option, 5 to 20 minutes. But for larger files, it's not a very good option to do this. It's better for like if the company has no issues with traveling cost, and like big tech companies don't have that. If you want to go from Delhi to Bangalore to deliver a file, you can certainly do so. This seems a very viable option. Now let's map this analogy with the concept of time complexity. This physical transfer is what we call as O of 1 or constant time approach or constant space approach. What does O of 1 means or constant means? Basically, like as the name suggests, no matter the size of the input, it does not matter if your file is 10 MB or 100 TB. It will only take you 5 hours. So it does not depend on your input. No matter the input, how large or small it can be, the time will remain constant. But for electronic transfer, it depends. It depends on your size of the file. So that we generate by O of n, denote by O of n, or linear time approach. As the size of the file increases, the time also increases. So let's see an example of O of n and O of 1. Oh, sorry. So how does an O of 1 function looks like? Now, here again, I will not be focusing more on the syntax because these are very basic program, and I'm assuming everyone can follow through this, and if it's only the pseudocode. So let's say if you want to print someone's name, okay, so you are getting a string name and you are simply printing it. Print hello name. Simple enough. No matter the length of the name, it can be 2-lettered name, it can be 10-lettered name, it can be 1000-lettered name. The time complexity, this will still cost you O of 1. This is what we call constant time. Now, how does an linear time looks like? Well, for linear time, for linear time approach, it's very simple to look at the code and tell if it's a linear time approach or not, because it will always have either a loop or a recursive call, basically. So if I give you an example of O of n, let's say you are getting a number n and you need to print all the number from 0 to n. You're simply printing I. This we term to as O of n. This is O of 1, this is O of n. Now, why is this O of n? because this loop will run for n times. If n is equal to 1, it will run for 1 time. If n is equal to 10,000, it will run for 10,000 times. If n is equal to 1 billion, it will run for 1 billion times. So it will depend. This loop, the number of times this loop will run will depend on the input. So this is O of n. Now let's also discuss about how O of n squared looks like. It's the same thing, just with a little bit, like it's a nested loop. So int n for I is equal to 0, I less than n, I plus plus, for j is equal to 0, j less than n, j plus plus. Print I plus j. Now, why is this order of n square? This loop will run for n times. We just now saw I is equal to 0, I less than n, right? This loop will also run for n times. Now, for each of the time this loop runs, for each of the time that this loop runs, the second loop, this one, will run for n times. So when I is equal to 0, the j loop will run for n times. So total number of times this program is running is, first time it ran n. For I is equal to 1, it again ran n times. For I is equal to 2, it again ran n times. And for I is equal to, like say n, it will again run for n times. So this will be n minus 1 because you are running it till it's less than n. So the time complexity is O of n square. There are more different types of time complexity, such as n of log n, square root of n, 2 to the power n, n factorial, and we will be covering all of these, in the future sessions, like when we will be starting our entire course. For now, I just wanted to give you a brief introduction of how this entire thing works. All right. So now let's move on to the